In this video, we are going to go over how to solve systems of linear equations by elimination. As you can see here on the screen, we have our 6 steps that we're going to be following listed out for you. Step 1, we need to choose a variable to eliminate. Step 2, use multiplication to get the coefficients of that variable in both equations to be the same number, opposite signs. Once we've done that, step 3, add your 2 equations together, which will give you a new equation. Step 4, solve that new equation for the remaining variable. Step 5, you're going to substitute the number value that you got in step 4 into one of the original equations and solve for the other variable. And finally, step 6, write your final answer as a point, so you would need to list your x-coordinate first, then your y-coordinate. Let's look at an example. Here we have a 3x plus y is equal to 18, and a negative 2x minus y is equal to negative 15. So step 1, we need to choose a variable to eliminate. Knowing in step 2 that we want same number, opposite sign, if we look at this strategically, our y's are already set up that way. We have a positive 1y in the first equation and a negative 1y in the second equation. So this is already set up for us the way we want, so it makes the most sense to choose to eliminate that variable first. So we're going to eliminate the y. Step 1, we've decided we're going to eliminate y. Step 2 is already done for us. We already have same number, opposite sign, so that leaves us at step 3. We are ready to add these 2 equations together. 3x minus 2x gives us 1x, plus y minus y cancels out, and 18 minus 15 is 3. So we've added the 2 equations together to complete step 3. Step 4 is solve for the remaining variable. Well, in this instance, step 4 is already done for us. We already have x alone on one side of the equation, so we know x is equal to 3. So we're ready for step 5. Go ahead and substitute that number back into one of your original equations. It does not matter which equation you choose to use. I'm going to use the first one. So 3, and instead of an x, we're going to replace it with what x equals, 3. Plus y is equal to 18. 3 times 3 gives us 9, plus y is equal to 18. Solving for y, we would need to subtract 9 on both sides. 9 minus 9 gives us 0, that cancels out, leaving us with y is equal to 18 minus 9, which is 9. So step 5 is now complete. We now know the value for x and y. We just have to write our final answer as a point on a graph. So my x-coordinate comes first, x is 3, and y is 9. We have our solution to this system of equations. Let's look at a second example. Here we have 8x plus y is equal to negative 16, and negative 6x plus y is equal to 12. Keeping in mind again our goal of we want same number, opposite sign when we're choosing to eliminate, it makes the most sense to eliminate y. Half of our battle is already done. We have the same coefficient. We have both of those with a coefficient of 1. All we need to do is change the sign on one of them. So to do that, we're going to multiply an equation by negative 1. Does not matter whether you choose to do that with the first or second equation. I am going to do that with the second equation. So I'm going to multiply that whole thing by negative 1. My first equation stays the same. I'm not messing with it. So we have an 8x plus y is equal to negative 16. That negative 1 needs to be distributed into all 3 pieces of that equation. So negative 1 times negative 6x. We're taking the negative 1 times the negative 6x. That gives us a positive 6x. And the negative 1 times the 1y gives us a negative 1y. Negative 1 times 12 gives us negative 12. We now have our two equations. We have same number, opposite sign now. So we are ready for step 3, which says to add them together. So if we add these two equations together, we're going to get a 14x. Our y's are going to cancel out, is equal to a negative 16 plus a negative 12, which gives us a negative 28. Step 4 says to solve, so we need to get x by itself. In order to do that, I would need to divide both sides by 14. 14 divided by 14 cancels out, leaving us with our x is equal to negative 28 divided by 14 gives us a negative 2. So we know what x equals. X is negative 2. Now we are ready for step 5. We need to substitute that back into one of our original equations. Does not matter which one we choose. I am going to substitute it into the first equation. So 8, instead of an x, I'm going to replace it with what x equals, negative 2. Then we had the plus y is equal to negative 16. Now we have to solve for the remaining variable. So 8 times negative 2 gives us negative 16, plus y is equal to negative 16. To get y by itself, I then need to add 16 to both sides. Minus 16 plus 16 cancels out, leaving us with a y is equal to negative 16 plus 16 again, cancels out, leaving us with a 0. So we now know our two values. X equals negative 2, y equals 0. All that's left to do is write our final answer as a point on a graph. So we need the x-coordinate, negative 2, followed by the y-coordinate, 0. And we have the solution to this system. Let's look at another example. In this example, we have 8x plus 2y is equal to 28, and 16x minus 9y is equal to negative 22. We need to choose which variable we want to get rid of. When making that decision, we want to keep in mind that we are trying to get same number, opposite signs. So if we look at the y's, I have a 2 and a negative 9. I have opposite signs, but there's not one thing that I can turn these into by only multiplying one equation. If I look at the x's, 8 and 16, I can very easily turn an 8 into a 16 and only have to multiply one of these equations. So I'm going to choose to eliminate x. And in order to get same number, opposite sign, we're going to need to multiply that first equation by a negative 2. So negative 2 times 8x gives us a negative 16x. Negative 2 times 2y gives us a negative 4y. And negative 2 times 28 gives us a negative 56. We did not touch the second equation, so we're just going to copy him down. 16x minus 9y is equal to negative 22. So step 1 and step 2 we have complete. Step 3 was to add these two equations together. Negative 16x plus 16x cancels out, which is what we wanted. We wanted to eliminate that variable. Negative 4y plus the negative 9y is going to give us a negative 13y is equal to negative 56 plus the negative 22 gives us a negative 78. Step 4 tells us to solve for that variable. In order to get y by itself, I would need to divide both sides by negative 13. So the negative 13s cancel over here, giving us our y is equal to 6. Negative 78 divided by negative 13 gives us 6. So step 4 is now done. We are ready for step 5, which is to substitute that number into one of our original equations. Does not matter which equation we choose. I'm going to substitute it into the original first equation. So 8x plus 2, instead of a y, I'm going to replace it with what we now know y equals, which is 6, is equal to 28. Now we need to solve for the remaining variable. So we have an 8x, 2 times 6 gives us 12. Now to solve for x, we need to subtract the 12 on both sides. So that gives us 8x. 12 minus 12 cancels out. And 28 minus 12 gives us 16. Now to get x by itself, we need to divide both sides by 8. And we get that x is equal to 2. Step 5 is complete. Now we have to write our final answer as a point on a plane. So we need our x coordinate first, 2, followed by our y coordinate, 6. And we have the solution to this system. Let's look at one last example. Here we have a negative x minus 3y is equal to a negative 21, and a negative 4x plus 7y is equal to negative 26. We need to choose a variable to eliminate. In this particular problem, doesn't matter which one, because we're going to have to multiply both equations by something in order to get the same number opposite sign. So I'm going to choose to eliminate the y. I can turn a negative 3 into a negative 21, and I can turn that 7 into a positive 21, which would give me the same number opposite sign. So to do that, I'm going to multiply the first equation by 7, and I'm going to multiply the second equation by 3. So that's going to give me two new equations. 7 times negative 9x gives me a negative 63x. 7 times negative 3y gives me a negative 21y. And 7 times negative 21 gives me a negative 147. In that second equation, I have the 3 times the negative 4x. That's going to give me a negative 12x. The 3 times the 7y gives me a plus 21y. And the 3 times the negative 26 gives me a negative 78. So I have my new two systems, two equations. Step 1 and 2 is done. Step 3, we are ready to add these two equations together. Negative 63x plus the negative 12x gives us a negative 75x. The minus 21y plus 21y cancels out, is equal to the negative 147 plus the negative 78, gives us a negative 225. We have to solve for x, so to get x by itself, we would need to divide both sides by negative 75. They cancel out over here, leaving us with ax is equal to the negative 225 divided by negative 75, which gives us a positive 3. We are ready for step 5. We need to substitute that into one of the original equations. Does not matter which one we choose to use. I'm going to use the first one. So negative 9, instead of an x, I'm going to replace x with the 3 that we know x equals. So we have the negative 9 times 3 minus 3y is equal to negative 21. And we need to solve for y from here. Negative 9 times 3 gives us a negative 27, minus the 3y is still equal to negative 21. To get y by itself, from here we need to add 27 to both sides. They cancel out here, leaving us with a negative 3y is equal to 6. To get y by itself, we need to divide both sides by that negative 3. They cancel out here, leaving us with y is equal to negative 2. Step 5 is complete. We just have to write our final answer in XY format. So the x value was 3, the y value was negative 2. And we have the solution to this system. I hope these examples helped you understand how to use elimination to solve a system of linear equations using elimination.